Lesson 6.4, Inverse Functions. An inverse relation or function interchanges the input and output values of the original relation or function. The graph of the inverse is a reflection over y equals x. So I have a graph over on the right, and if you remember from geometry, this would be our reflection, y equals x. So the original function would be on one side, and its reflection would be on the other side of that red line. To find the inverse of y equals 3x minus 5, we're just going to switch the x and y values. So it becomes x equals 3y minus 5. Now we need to isolate by adding 5 to both sides. So x plus 5 equals 3y. We need to isolate the y further, so we're going to divide every term by 3. So 1/3 x plus 5 over 3 equals y. The notation would be that we have to change this y to f. We have our little -1x equals 1/3 x plus 5 over 3. This is saying that this is the inverse of the function that we started with. It's not a raised to the power of -1, it's the inverse of f. So when we solve f and we solve its inverse, we should get back to the same x. This notation we'll be looking at on the next slide. So instead of writing f of g of x, we could write f of the f inverse. So the purple and the green are interchangeable. This notation should look familiar. This was at the bottom of the last slide. We are trying to determine if the two functions are inverses. So we're going to start from the middle, and notice we start with the function, and then on the right hand side we're going to have the inverse of the function. All right, but we're going to start over on the left. So because we're starting on the inside, we're going to go over to the values they have for our inverse, and we're going to put those inside the parentheses. So 1/3 x plus 2/3. But that it only represents the inverse. Now we have to include the values from our function. So those are going to go on the outside. This is replacing the x. So we have 1/3 x plus 2/3, and then we have the -2. We distribute the 3, so that comes out to x plus 2 minus 2, and we end up getting x. So now let's tackle the right hand side. So now, because we're working with the inverse, the f of x goes inside the parentheses, so that would be our 3x minus 2. And now we have to include our inverse values. So 1/3, and then instead of writing this x, we're writing 3x minus 2, and then we have to still include our plus 2/3. We distribute the 1/3 in, so we get x minus 2/3 plus 2/3. These values will cancel, so it equals x. So we just verified that these functions are an inverse of each other. Given a graph, we can determine if its inverse will be a function. So let's first look at this second sentence. We can use the vertical line test to determine if a graph is a function, and we did this in Algebra 1. So if our vertical line just goes through one point, we know that it is a function. Now we're going to, just looking at this exact same graph, we can decide if its inverse is a function, if it passes the horizontal line test. So when I draw a horizontal line through the graphed blue line, if it only goes through one time, then its inverse will also be a function. You know a quadratic or a parabola is a function. It passes the vertical line test. It goes through just one intersection. However, you can see that when we try to do the same thing with the horizontal line, it goes through 2 points. So its inverse is not a function. If it passes both tests, it's a 1-to-1 relationship. Here we are asked to graph the function and its inverse given this restriction. X is less than or equal to 0. So that's going to tell us how to proceed with the problem. So we know we have to start with y equals x squared plus 2. We are going to switch the x and y values. So x equals y squared plus 2. I'll subtract 2 from both sides. And then we need to take the square root of both sides. These two say the same thing. We have a plus or minus because we had an even root. However, remember we have this restriction, so our inverse is going to be the x is less than or equal to 0 tells us it's going to be non-positive values, and that's why I have the negative in front of the square root of x minus 2. All right, so we're going to make 2 tables of values. All right, so we're working with our original function first, and it says x is less than or equal to 0, so we'll put in a 0. 0 squared plus 2 is going to be 2. If I put in a negative 1 times negative 1 is 1, and 1 plus 2 is 3. And if I put in a negative 2 times negative 2 is a positive 4, and 4 plus 2 is 6. So now I'm going to plot those 3 ordered pairs. Now for the inverse. So if I try to put in a 0 underneath the radical, I'm going to end up with a negative 2 under the radical, and then we're messing with imaginary numbers. So let's try a 2, because if I say 2 minus 2, that's going to be 0. If I say 3 minus 2, that will give me a 1, but I have this negative on the outside of the radical, so negative 1. And if I put in a 4, that's not good. 5, that's not good. So let's try 6. If we put in 6, we get 6 minus 2 is 4, and then the square root of 4 is going to be 2, but then it's a negative 2. So 6, negative 2. And now we can graph these 3. Okay, 2 things here. If you remember from our first slide, we said y equals x is our line of reflection. So you can see that the function and its inverse look like a reflection. And also notice in our tables, we have 0, 2, then we have 2, 0. Remember at the beginning how we switched the x's and the y's? Negative 1, 3, 3, negative 1. So the x and y values just switched.